Okay, hi everyone, and welcome back. Last lesson, we defined AI and we looked at the different types of AI and their capabilities, and we differentiated between them. In this lesson, we're going to look at machine learning and machine learning essentials, basically, right? We're going to just explore this um, technology that is absolutely game changing. And this is a technology that, transformed AI from research curiosity into something that basically powers billion-dollar companies, right? I'm going to explain it in a way that kind of helps you understand crystal clear what, AI is and, machine learning is and how it works. So we're going to start by using an analogy. Excuse me. So let me start by asking you a question. How did you learn to recognize dogs? Right? Here we see a picture of a mom showing her kid different types of dogs on a platform. And by the way, just for transparency, this was generated by AI, right? With a prompt. Um, but let's go back to, how you learned to recognize a dog. I don't think anybody gave you a textbook recognition saying, "Oh, a dog has 4 legs, is this long, has fur with a tail, or has a 2 inch." No, no. I really don't think anybody did that because as a kid, how would you even know how to read or even understand what that meant, right? It would be ridiculous. So instead, I think what happened, someone probably showed you different types of dogs, and those who are dog lovers, you see a poodle, maybe a German Shepherd, you see a cat, and then you see another dog, and you just saw different variations of dogs, the puppies, the bigger ones. And when you saw a cat, someone told you it wasn't a dog, so you could see, the differences. After maybe seeing that 20 times, 30 times, your brain figured out the pattern, right? And then now when you see a dog that you've never seen before, you even recognize the breed if you know what breeds are. You see the bigger dog or the smaller dog, or the smaller puppy, like my kids would do. When they see a puppy, they know the difference between a puppy and a dog. Because most times you see a puppy, like, "Oh, that's cute, it's a puppy. Oh, that's a big dog. Oh, this is a cat." So they see different things and you keep voicing out to them that, hey, this is what it is. And they recognize, the brain just learns, to recognize the concept of dogs from cats from the examples they've seen. Now, that is how machine learning works, right? Um, Machine learning is basically, you know, yeah, that's basically how machine learning, works. And machine learning is a subset of AI where computers learn from examples rather than following explicitly programmed rules. The same way you learn to recognize different colors, the same way you learn to recognize different shapes, the same way you can differentiate an apple from a mango, from a banana, right? And instead of telling the computer every possible rule, you show it thousands and thousands of examples to let it discover the patterns on its own and learn from those patterns, right? Now, let me show you the difference. Let's see, let me show you the difference of the, and this is just going to make it a little clearer, I hope, right? Now, with traditional programming, you would give it explicit rules. The computer follows the rules and it produces the output. For example, you could say if the temperature is below 68 degrees Fahrenheit, turn the heat on. If it's above 72, turn it off, right? That was traditional. You program the computer to do that, and anytime it got to 68, it was going to turn the heat off. But now with machine learning, you give it different examples, so you feed it tons and tons of data about temperatures to find the patterns within that. So you provided examples of correct answers. The computer will find patterns, and then the computer would apply those patterns to new situations that it's never seen before. So probably 10,000 temperature preferences or even more. Usually it's more, and then the system learns the patterns and it would predict your preference, right? So let's see. Remember from the previous lesson we did talk about the spam filter revolution as well, and how the old way was rule based, where engineers would write thousands of rules and spammers would always find a way, you know, to adapt instantly by changing some of those rules from free to just putting different things, explaining different words, using images to either play catch up or to change this, right? Now, that was the old way. If the email contains free money, then do this. If it contains this, then click here now and do this. If it does this, then do here and do this. Those are some of the rules that it was being given. But today, for the machine learning system, which is the new way, you know, what happens is it would gather training data. It will collect about 1 million emails. About 500,000 of them will be spam, 500 legitimate, and they will all be marked, right, by the users as legitimate and spam. Now, it will let the algorithm learn. So the machine learning algorithm analyzes all these 1,000 emails looking for patterns, and it will discover things like spam emails are often sent maybe at a certain time, 3 a.m. They use all caps more frequently. You know, spam comes from certain domain patterns, maybe not legit domains, and then they have specific writing styles, grammatical patterns. So it basically just discovers hundreds of subtle patterns, many that humans never would have noticed through, you know, or even thought to program, right? Then it would create a model, right? So this the algorithm creates a model that says if an email has this combination of patterns, this is the probability of a spam. Maybe 94% send it to spam, you know, and usually 99% of that will be done. Then now when the new email arrives, the model checks it again. All the learned patterns and all the patterns that learned and predicted, whether it's a spam or not, it looks at all that, analyzes, and then sends them to spam or not if they are not. Now, here's the magic. When spammers invent new tactics, users mark those emails as spam, right? Today, when you receive a spam message into your email, sometimes you would mark it as a spam, right? The model also retrains with these new examples that are being marked, and it automatically adapts. So no human has to write new rules. You are also helping teach, you know, the algorithm how to identify these spams, because once you mark that email as spam, the next time the same kind of email is coming, it knows immediately this is spam and it sends it to spam, right? And that's just the power of machine learning. It scales, it adapts, it discovers patterns humans might completely even miss, and all that. Now, there are different types of machine learning system, right? The power it scales, adapts, and discovers patterns that humans might miss, right? Now, there are different types of machine learnings. We have supervised learning, which is kind of like learning with the teacher who has the answer. Unsupervised learning and reinforcement learning. So unsupervised is finding patterns without a teacher. Reinforcement is learning by trial and error with rewards. And we're going to examine all these different types of machine learning, right? Now, let's start with the very first one, supervised learning. Think of this as really learning with a teacher who has the answer to the questions, right? You provide the algorithm with input data and the correct answer, and it learns the relationship between them. So we'll use the example of predicting house prices, right? Let's say you feed the algorithm data on 10,000 houses that have already been sold. You're a real estate agent, right? You say the first house, maybe 12,000 square feet, has 2 bedrooms, built 1995, is downtown, sold for $450,000. The second house, you feed its own information. The third house, you feed its own information. So When you do this for all 10,000 examples, the algorithm learns the pattern. It starts from the square footage, and if it's highly correlated with the price, then location matters a lot. Then the age, kind of has a moderate impact. Then the number of bedrooms also matter, right? Maybe not as much as the size, but we do know that it matters. And now, when you show it a new house it's never seen before, what do you think is going to happen? Let's just say you give it a house now that has 18,000 square feet, 3 bedroom, 2005 in the suburbs. It's going to consider all the other factors that it looked at when you fed the 10,000 examples to it and come up with averages, right? And it's going to predict maybe this house is going to sell for about $575,000, depending on the location, square footage, and all that. It has already considered all that in the algorithm and calculated it, right? So where is this used? That's just basically how supervised learning works. You give it input and the result, or an answer. You tell it something with an answer. Maybe you're measuring, you're a chef, I don't know, or whatever. We use the example of a real estate agent. You fed it information, tons of information about houses. It helps you predict houses because you gave it the different values and the corresponding prices for those houses with the factors, right? Then it will help predict. It's used in medical diagnosis where you give it symptoms and then you predict the disease. Or somebody comes to you, the person says they have a headache, they're throwing up, their eyes are constantly wide, they can't deal with smells. There's a few things you can do. You can either look at if they have something like COVID or maybe they're pregnant, right? You give it all those values, and then when you come and give it some of those different symptoms that you're experiencing, you can predict the disease. It's the same thing with credit scoring. You give it your financial history, credit worthiness, right? And financial institutions use this a lot. Today, I actually worked with a machine learning team in one of the Fortune 500 companies, and this was one thing that they did a lot. They would feed with petabytes of data in your financial history, and every time you came to apply for a loan, the machine learning algorithm goes to see if you qualify based on historical data that they had collected, right? And see how if you qualify for credit or credit card. Then we also have image recognition, and where you give it different pixels and say, hey, this is a cat, this is a dog. And if you're seeing, there's so many other videos out there where you see cats with cookies and dogs with cookies and all that, and they'll try to predict which one it is. Depending on the pixels, it will easily tell you which it is. Then customer churn prediction as well, the behavior was it cancel. And customer churn, if you don't know what it is the rate at which you would retain a client, right? Or a client would leave you after a certain period. So they look at the behavior of the client and see if they're going to cancel maybe a subscription, or they're not going to cancel a subscription. I think Netflix, companies like Netflix and Amazon, they use this a lot as well. Then fraud detection. The same team I worked with, we also had a fraud detection team, that studied transaction patterns and saw if these were legitimate or not, if these were fraudulent transactions, and they would block them before they even arrived to your card. So that is basically how supervised learning works, and the different types of supervised learning or applications of supervised learning. Now, let's talk about unsupervised learning. Let's think of this as, learning without a teacher, self-learning, right? You're self-taught. Finding patterns in data when you don't even know what you're looking for. You give the algorithm data with no labels and just say, find interesting patterns. It has to go study it on its own. right? Now, let's look at something like customer segmentation. I don't know if you can relate to this, but I'll try. If you don't, we can look for another example, right? So, a company has close to 100,000 customers. Let's do Amazon. They feed all customer data into unsupervised learning algorithm by age, location, their purchase history, their browsing history, the time they spend on the site, the average order, that they do. Let's just say you own that and you're trying to, figure out this for your company. You don't tell the algorithm how many groups there should be or even what to look for. The algorithm just analyzes the data and maybe will discover 5 different groups. Group 1 is the young professionals, those between 25 and 30, who buy during lunch breaks, prefer premium brands, luxury brands. They use their mobile phones a lot to shop, and those are like their top clients. Now we have the parents, 30 to 50, who buy in bulk, are very price sensitive, use coupons, purchase in the evenings and weekend, and only buy family oriented products, right? Then we have the retirees who are 60 plus, leisurely browsing patterns. They call customer service frequently, complaining. They prefer traditional brands and they are very loyal. Then, of course, the deal hunters who are just at any age. Only look to buy items on sale. There's a couple of us who do that. Compare prices extensively. Use browser extensions for discount codes. Hunt, what is this called? Referral codes and all that. And then we watch reviews a lot. You would read reviews and read before you buy them. Then the impulse buyers, who are 20 to 40 and respond strongly to recommendations, high cart abandonment rate, and frequent small purchases, right? Those who maybe follow social media influencers and are just buy because they're impulsion. Because maybe one of their influencers posted something that they like, they feel like they want to buy it, they go add it to their cart, then they abandon the cart, feel like they want to buy it. So those are the impulse buyers, right? And then, but you realize that nobody told the algorithm to look for these groups. It just discovered them, split them into different groups naturally, by studying patterns in the data. Now, marketing can create targeted campaigns for each of these segments, right? And it's very powerful for market segmentation, finding different customer types, like we did, anomaly detection, just spotting unusual patterns that might indicate fraud or system failures. This is also used a lot in fraud detection. Anomaly detection is used a lot in fraud detection. You give it tons of data for fraud. You will study the different fraud patterns and segment it into different components. Then recommendation systems, finding similar items or users, and then of course data comprehension, right? Finding efficient ways to recommend or represent information. So we're seeing the different types of customer, of the way it is, and then where supervised learning is being used or leveraged, right? Now, let's look at reinforcement learning. This is basically trial and error with rewards and penalties, right? I know I have here the example of, mastering chess, but I also want to use that of self-driving cars, right? But let's look at mastering chess. I don't know how many of us play chess. I don't, but it does look like it's used as well in these cases. It tries to find different actions, receives feedback on results, rewards, or penalties, and it learns from actions that lead to better outcomes. Just a very basic example: when your kid is growing, for those of us who are parents, how do they know right from wrong? When they do something bad, you put them on timeout or you punish them. You take a toy away from them. When they do something good, you give them a candy. You give them maybe ice cream. You give them something that helps them motivates them, right? And that is how they learn. Every time they do something bad, they're on timeout, they know that. Anytime they do something good, they are rewarded. That's how they learn the difference between right from wrong. It's the same thing with the others, right? AI with chess, when it's learning to play itself, it will make random moves. If it loses 12 times, it would receive a penalty. They reduce points from it, so it knows, and it's been programmed and coded to know that it's receiving points if it does the right move, and points will be deducted if it makes a wrong move. So anytime it makes a right move, it gets points. Anytime it makes a wrong move, points are deducted. So after making the wrong move, what it tries to do is to find another way to make the right move, right? Just like self-driving cars, when they are learning to drive. If you put it on the road and just say go, discover to go. If it keeps driving straight, you keep adding points as it goes. If it hits a tree, you reduce points from it. It knows that, okay, I made a mistake. I can either go left or right. It will try going right. If it hits another block, you reduce points from it. It will come back. It can't go this way again because you had already reduced points from it. So it looks for the next way to move, right? And it moves towards that direction. If it goes through, you added points, it knows to continue. If it continues and then hits another block, it knows to, re-navigate itself. So that is basically what reinforcement learning is. It's a pointing system where you add and subtract points and it self-learns, right? From its examples. Till it receives all the positive points and it knows that, okay, and this is how chess, learned to play itself to a point where it was able to beat the human, the best human in the world, right? So yeah, with chess, the AI was basically programmed, with different chess rules or strategies, just beyond the legal moves, and it learned entirely by playing millions of games and being rewarded for wins and getting penalty for losses, and just kept improving like that till it was able, to learn and beat the world champion, Now, reinforcement learning, its applications. Game AI in gaming, chess, video games, of often superhuman, performance, right? In robotics, learning to walk, grasp objects, navigate environments, and it's the same thing with robotics and autonomous vehicles, right? If you're training it to walk somewhere, it makes a move, it hits a place, points are reduced. It doesn't, you add a point, it keeps moving. You add another point, it keeps moving. And you program it for certain distances, right, that it will get to. Then autonomous vehicles, learning to drive through simulation and practice as well. Then resource optimization, energy grids, data center cooling, and trading algorithms, So these are the different places where reinforcement learning is being applied. Let me put it that way. Now, what is the process of machine learning, right? No matter which type of machine learning you use, whether supervised, unsupervised, reinforcement learning, they all follow the same steps. So I'm just going to walk you through this to understand what actually happens when someone says, I am building a machine learning model. The first thing is always to collect relevant data. You gather thousands to millions of high quality data, right? And it takes about 40% to 50% of the time. And just so you know, in machine learning, we say garbage in, garbage out, which means whatever you spit into the algorithm, you're going to get the same results out. So if you don't clean your data very well, if you don't get high quality data, you put that data into your algorithm, your output is going to be garbage as well. So you want to be careful the kind of data you're collecting. Data here is very, very important. As you can see, it takes about 40 to 50% of the project timeline, right? And then preparation, cleaning it, fixing the errors, handling missing values, organizing it, ensuring it's representative of the real world to avoid things like bias, be it historical, human, whatever type of bias it is that you're trying to avoid. Make sure it represents all the demographics that you need for that particular um, yeah, data or project that you're working on, right? And then choosing the right algorithm, selecting the right approach for your specific problem, because different algorithms have different strengths. So you want to make sure that you're choosing the right approach for your either supervised and unsupervised. You're choosing the right one, right? Then training your model, feed the data to your algorithm, then you let it find patterns, and this is the actual learning part where the magic happens within minutes to weeks, depending on the complexity. It takes time to train itself. Now, with modern tools, it might take minutes to weeks, depending on the complexity, because a lot of improvement has been done and it's easier to train these models, right? Now, testing your model, you're looking for accuracy on the new data it's never seen before. And this is crucial because you need to know if it actually learned generalizable patterns or just memorized the data, right? And then, of course, deploying your model, you put it into production where real users interact with it, and you make it accessible to your applications or your API. Then you monitor and retrain. Always monitor and retrain. Retraining is very important because you're going to be getting new data, new sorts of data, new forms of data, and you want to retrain to make sure that it's representative of that data over time to avoid any compliance or regulatory issues, right? That come with retraining. It's always an ongoing process. Models need maintenance, just like any other system. They need to be maintained, right? Yeah, so that is where we are with the machine learning process. Now, why is machine learning revolutionary? Here's what I want you to understand about machine learning, right? For traditional rule-based systems, they have a ceiling. A human expert can write maybe 100 rules if they are motivated, maybe 1,000 if they're obsessed, right? But that's the limit of the human capacity to write the rules or articulate these rules. Now, machine learning can discover hundreds of thousands of patterns from millions of examples given to it. Patterns too subtle, complex, or even just humans to accumulate. Patterns we didn't even know existed. Machine learning would identify those patterns, right? Let's look at something like a medical diagnosis. A doctor that has even 30 years of experience might have seen, 10,000 patients? That's really good experience, right? But a machine learning model trained on medical records from 10 million patients, it's seeing patterns that no individual doctor can even encounter in his lifetime, right? So, it just makes it a whole lot different. When we're talking about machine learning, how it discovers these patterns, and how transformative it is in different industries, right? Handling just complex problems from real world data and avoiding that rule-based system, that was limiting in so many ways. Now, for this lesson, this is your key takeaway, particularly about machine learning. So they have about 100 plus patterns that machine learning can discover with its complexity. 100 million data points that it can analyze, then 24/7 continuous learning. So it learns non-stop. Unlike a human being where we have a time clock, right? When it's time, we're exhausted, that's it. You can't push it past that. But machine learning, it's a machine. It's going to learn and keep learning, different patterns. It doesn't get tired. It does not stop. It just keeps learning, right? Now, as I said, what is one thing that you should take out, from this lesson? Machine learning is revolutionary because it scales, it adapts automatically, and it discovers patterns that humans miss. It does not mean it's replacing human intelligence. Again, it does not replace, it augments. It's augmenting it by handling pattern recognition in massive data sets, while humans provide the judgment, ethics, and the strategic thinking. right? So this is really one thing that's important for you to take out of this course if you're not now. Well, for our next lesson, we're going to look at artificial neural networks and how they're also powering this supercharged technology, right? We'll explore the architecture inspired by your brain that powers some of the most advanced AI systems today. Now, in this course on machine learning, we learned different things: what it is, the three different types of machine learning, their capabilities, their various use cases, how they work, looked at some real world applications, particularly within the medical field, and chess as well, you know, self or autonomous vehicles. And yeah, I hope this really helped clarify the difference between the types of machine learning: supervised, unsupervised, and reinforcement, how and where they are used and leveraged, and how it's helping power technology in today's world. We're going to look at artificial neural networks next. Thank you so much, and see you in the next lesson.